So I've already done a lot of videos creating AI agents on this channel, and OpenClaw is the talk of the town, and we are working with OpenClaw in this video. Plus, how can we get in memory to that OpenClaw, because our OpenClaw might suffer from amnesia. It might not be able to remember the context across different agents, across different machines and across different sessions. So we are solving this problem here. It is very important video. If you're new to this channel, make sure you hit that like button. Subscribe to this channel for more such amazing content coming ahead. So why do AI agents forget? Let me give you a very simple example. For example, there's session 1 in which I am asking to an AI agent like OpenClaw, hi, my name is Ursh and I create content. And maybe it's the next day, or it is a different machine, or we are running multiple agents in parallel. And in the session 2, I ask it the same question again, who are you? So it might not be able to remember that. So it has the memory layer which is stored in the local storage, and it might not travel with the machine, or it might not move from one session context to another session context, or it might not perform between different agents. So generally why this happens, because as I've already told you, memory, it is stored in local files. There's memory.md in your laptop. It's gone when you switch machines. We don't want that. Second, when the session ends, right, we wipe off. There's no persistence. Every session starts from 0. And third is multi-agent chaos. Like if you have two different agents, two separate files, and they should not, like, they don't have context of what's happening. They don't have any shared memory. So we are going to solve that today. How we are going to solve that today? We'll have OpenClaw open. We'll set up OpenClaw, and we'll have a special memory layer mem9 that is backed by TiDB Cloud. I'll tell you why we're using TiDB, what's the use case of TiDB, and we'll get the final agent that will exactly remember and will solve all these three problems. Now this will help our agents have persistent memory and context over a longer period of time. Now let's see how it works. So this is OpenClaw, which was released and which was acquired by OpenAI very quickly. And you know, this is something that has been the talk of the town, and I know most of you would be aware. So you can set this up and it can do all things for you that you actually need. It can clear your inboxes, send emails, manages your calendar, checks in you for flights. These are some of the things that they've written, but it can do way more than that. It works with any and every extension, be it Telegram, Discord, WhatsApp, Signal, Gmail, browser and all. And you can set this up. So you can look out for steps on how you will be setting this up. So there's a quick start here for different things, like if you want npm install, if you want Hackable, macOS for one-liner, you can install this, how it runs on a machine, or how persistent the memory is, how it controls your browser, how the skills and plugins thing help. But I've set this up. You can see this is how it looks like. It's the chat window wherein you can chat and ask for it to do anything. I'll do a simple example. Like there are 3 ways in which I'll showcase you why it's not able to hold the memory. First of which is session state. For example, if we move from one session to another session, the context or the durable memory, that is somehow lost. So let's see. Let me give it an example. For example, I ask it to remember these 3 things. The project name is Falcon 27. Neha owns infrastructure, and the launch review is Friday at 4:10 p.m. So I asked it to remember this. Let's see if it is able to remember. Yeah, so now it has remembered all of this. If I'll ask the same question here, when is the launch review? So it should be able to give me the answer, because that is stored in its memory, Friday at 4 p.m. Now I'll close this session and also wipe off the session state and reopen another one. Let's see how it goes. For this, we need to clear the sessions.json file just to demo you, and also I'll close this session. Now I have this up again. I have removed the session history, and this is the new session. I'll ask the same question: who owns the infrastructure? Now it has given me a very weird answer. I told it some different name. It is not able to get that context. So this is the problem that you see, right? Second problem would be, for example, the memory that we are storing, it is stored in the local database for this particular machine. For example, if I change the machine, then that context is again lost. In OpenClaw, there's a special file known as memory.md in which that is stored. So if I delete that memory.md, the context would be gone, and I need to get back to it. So I'll just get it some more things. Now for example, I'm giving it this context. So let's save this context. Now I'll ask some question: who owns the front end? So like Priya owns the front end, right? Now this is working. Now This memory is stored locally in my PC. For example, this is the memory that it has. So I have just asked it to get this up. So it has this context now. Priya owns the front end, Rahul owns the back end. Check staging before and after debugging. Now I'll delete this memory file. For example, I just want to showcase that if you're changing the machine, right? And now I'll try getting the same context here. Now after deleting that, I've started it again. Let's see if it is able to get the context. Who owns the front end? I've just asked it one. Let's see if it has the context. So you can see it has no context because we changed the machine, we deleted that memory folder. For example, if you move from one PC to another PC, there's no local memory available and you lose the context. So this is the problem, and there's one more problem of multi-agent. If there are multiple agents doing different work, for example, you have a coding agent or you have a testing agent, so the context or the memory might not move from one agent to another. So that's another problem. Now how we are solving is, let's see. Now here comes something very important, that is Mem9, the memory layer that we'll be using to build something in this video. So what is Mem9 and why we are using Mem9? So it's a persistent cloud memory infrastructure for AI agents. That is, it will store that automatic memory that can be later used for retrieving for any other agent, any different machine or any other use case. So what does it do? It basically does three things. First, it captures, second, it stores, and third, it retrieves. And when I say capture, it captures only the relevant parts of that conversation, not dumps entire conversation into the memory. Second is it stores it persistently, that is, it is saved across different sessions, different machines and different agents. Third, it retrieves basically what's important for the conversation. It retrieves that for the next conversation and it basically injects into that agent. For accessing this and building multiple agents or doing anything, you need to have only one Mem9 API key, and that corresponds to one memory space. In the video, I would have used API key somewhere, tenant ID, tenant key, tenant only key. So I think they all refers to what I mean to say by Mem9 API key. We also talked about automatic memory, like what exactly does Mem9 store? So it is, so you can call it as automatic memory. So it stores the information that is worth retaining long term. So it looks out for that information in the context, in the conversation that is worth remembering for a longer period of time, and then retrieves relevant memories before the next conversation. So it keeps those memories ready. Whenever there's context, whenever there's a retrieval request, it has those memories in hand to get things out, and it injects only those relevant memories to the prompt. So what it basically does, it has two things. One is to store and another is to retrieve. When I say store, it analyzes and decides what exactly to remember, and it can be based upon user preferences, key decisions or some facts. And it also retrieves, that is, it finds stored memories which are relevant to the conversation, and these relevant memories are then retrieved via any prompt to that agent. Now why this entire problem comes back to the first place, and what's the solution we are choosing, right? So generally there's a three database problem. Any AI agent that you are currently working on, it calls upon three databases for different things, right? I'll give you an example of a simple library. You go to a library and you want to find a specific book. Now how can you find a specific book? There can be three ways of finding that specific book. One, two. For example, the first way is the card catalog that you get, in which you can see this specific book is placed at number 42 and you can go and get that. So this is a card catalog. Second way, for example, you go and you give a fuzzy query like help me find out books which are similar to this one. It's not very clear, but it's a fuzzy query, right? It's a fuzzy query, books similar to this one. Or it can be third one, wherein you are simply using something like Control plus F to find that specific book. So there are three different ways for three different use cases of what kind of thing you are looking at, and the same is here, right? So what you call this card catalog thing is, it is the relational DB, how relational DB functions. How the book, I want a book similar to this, right? It's a fuzzy thing. It's not very correct. It's not very concrete. This is what Pinecone or a database like Pinecone or VectorDB would store. And third is like Control F, wherein you can exactly find out the specific part, the specific book that you want to have. And this is Elasticsearch. But it comes with a lot of hidden costs. For example, if relational DB updates, then vector DB would be stale, right? So there's always this lag between different databases if you're working across 3 DBs. Second is 3x infra cost. If you are working across 3 different databases, you're getting 3 bills per month, and that leads to an extensive cost for setting up a thing like this. Third is you won't have any transactions. Like for example, your relational DB is giving something else, vector DB is giving something else, Elasticsearch is giving something else, and your agent is not able to make up what is correct. Whereas for a database that we are talking about, it would give you everything very consistently. Now, why I explained it in that context is, what if all three things, all three features of these three different databases are packed up in one? That's what TiDB Cloud looks like. I'll not take a lot of time here. It has properties of relational DB, it has properties of vector DB, it has properties where you can search in full text. It is MySQL compatible, it has full text search native, and it has built-in vector columns. You just need to have one query with one connection and you get one bill. So all three problems that we discussed there are somehow solved using TiDB Cloud, and your agent gets full context with one query that is consistent and transactional. And we are going to see how this TiDB Cloud, which is backing the Mem9 that we'll use in our OpenClaw, saves us from a lot of things and saves the problem of consistent memory, persistent memory that we saw just before this. Also, just to put this up in one more example, like for example, I give this query, your agents give this query, what did I talk about last week for my fitness goals? So TiDB runs this one query. There are three different things that can happen: relational, vector, and full text. So all of this is combined and your agent gets the full context. For example, relational, you'll have, which will fetch the user profile and a week, like in the last 7 days. Vector profile would be like, for vector, it would find fitness goals, right? So it will perform ANN on fitness goals. And third is full text, which will search keyword wise like fitness, workout, or something similar to that. Now at the end, our agent would have full context and it responds with full context. Now let's see how it works in action. So as I've already shown you, right, this is the problem and how we'll be solving this. So we have something known as Mem9, which is an unlimited memory for OpenClaw. We know that agents forget things between sessions, right? We have seen that. How Mem9 fixes that? It has that persistent memory infrastructure with hybrid search, with shared spaces and cross agent recall from first write to forever, and it is backed by TiDB Cloud Zero. Especially this database is built for agents, which is more AI ready, which is fully MySQL disposable and zero. Like it is in milliseconds, no cold start. And I've already explained you how TiDB works. It has features of all databases that we want and how can you set it up. So these are the steps to set it up. I'll set it up very quickly and showcase you on how it works. So this is the interface of Mem9. It's the memory layer for OpenClaw, and with respect to security and privacy, it handles data very carefully with encryption, with access controls, auditability, isolated data handling, and production grade cloud infrastructure, and you can trust it. Now let's put this up in our OpenClaw and see what it happens. Now how to set this up, let me show you. We'll first provision the TiDB Cloud Zero. When I say TiDB Cloud Zero, so these are the steps for creating an instance. I'll try creating an instance. I'll copy this and I'll quickly start the terminal, and this will help me set up the instance, and I will get a few things here, right? So these are the things that I want to copy paste from here. Now I got a username, password, and a claim URL for TiDB. Let me just claim this instance, setting up my starter instance for TiDB. So it will help me open. I'll copy this instruction for agent. I'll save it here. Permanent TiDB Cloud Starter. Please update your database connection to use the new connection string and verify the connection works. So I'll quickly open this in TiDB Cloud Console, and this is how the TiDB Cloud Console looks like. Click on connect to get the details of your host, your port name, your username, database password. Database name is mnemos, and this is the connection string that you have. Then you need to perform 2-3 steps. I'll not go in depth of these steps because you can do it yourself. You need to create a database for your Mem9. You can connect with the MySQL client and create the DB where you can put your username, your password. I've already done this step, so I'm not doing it again. And after that, you need to get the Mem9 server code. You can clone Mem9 locally with git clone your repo name and cd. You move it to that repo, right? These are the step number 3 and step number 4. Once you do this, and also the next step after this is to configure your Mem9 to use TiDB. So for Mem9 to use TiDB, you need to export, you need to keep the exact names which depend upon the repo, but you need to set this up, set your environment variables. For example, DB host, DB port, DB user, DB password, and DB name. So this is what you need to set it up. If you want to get these steps done via any code CLI, be it Cursor or Claude, you can get these up from there itself. So these 3 steps are very important because for third step, we are creating a database for our Mem9. So this is the database that our agent will be using for long-term memory retention, long-term persistent memory store. Now The fourth step helps Mem9 becomes the memory layer between OpenClaw and TiDB, and I am setting this up here. And this step 5 will help me set up or configure my Mem9 to have a tenant key, and if any agent uses that tenant key, that will share the memory. So once you do these 3 steps, then you need to run this command and check for your memory server. It is there, memory server would be there, and you will get this ID. So this is a tenant key, and this tenant key will help us configure our TiDB client for our agent. Now how to set up Mem9 for your OpenClaw? I'll just simply ask it to read this skill and follow the instructions to install and configure Mem9 for OpenClaw. I'll just quickly put this up and let's see what happens. So now it's going to install configure Mem9, but the skill says I need to ask one setup questions, create a new Mem9 API key and reconnect an existing one. If you reconnect, paste the API key. I need to create a new Mem9 API key and reconnect the existing Mem9 API key. So I need to have the API key. So now I'll simply ask my OpenClaw to read Mem9 and follow the instructions to install and configure Mem9 for OpenClaw. Let's see what happens. So it is going to install which setup we want, create a new Mem9 API key, reconnect an existing Mem9 API key. If choose to reconnect, place your existing API key. So I'll just paste the existing tenant ID or the key that we had. So it has started the reinstall and let's see what it does. So we have configured Mem9 and TiDB and we are trying to connect it to our OpenClaw. So now Mem9 is configured and installed. What happened? Mem9 is installed successfully. OpenClaw JSON was updated. Gateway restart was scheduled. OpenClaw status. Now you can see in this TiDB Cloud 0 also we have mnemos wherein memories, tenants and upload tasks are there. You can see our import data, export data, and this will come up once we do something here, and this is the overall overview. So these are some of the request units that we have been trying out, but let me just ask it the same questions. The project name is Falcon 27, Neha owns the infrastructure, and the migration deadline is April 15th. So it has got the project note. It will save locally. If you want, I also fold this into a cleaner long-term note once there's a bit more project context. You can do it into a cleaner long-term note. Right, so it has saved locally also, and it is saving it in the longer term note also. Now the same way the last time we deleted memory from everywhere, right, memory.md, and we also closed the session when we opened it again. We'll do it again and let's see if our TiDB or Mem9 is able to get this up. So now this is OpenClaw, and I'll ask the same question again. Let's see if the data in Mem9 that is stored, we can retrieve it or not. What's the project name? Yeah, so it has retrieved that data. So it has retrieved that data, and you can see this in front of you that we have Falcon 27 coming up. So now within our TiDB console also, if you go to SQL editor and run this simple query, you can see the results. There are IDs, there are tenant IDs that you can see here, and we can see that how it is configured. And in our tenant DB, we can run this command to see what exactly it has stored. You can see it has stored migration deadline is April 15. Neha stores infrastructure. The project name is Falcon 27. This is the source is OpenClaw demo, and it is created at this timeline, and these are the IDs. So this is how database is stored in TiDB Cloud 0, and we have Mem9 configured for our OpenClaw agent. So now one more use case that I would want to show is how this memory is stored and retrieved across different agents, and I'll show you via terminal. Let's do the terminal demo also. So for example, on the terminal, I give this command. So for example, this is the API key that you see. For that API key, I have an agent ID known as coding agent, and I store this particular content information that project Falcon 27 uses feature flags to get the billing migration, and Neha owns the infrastructure approvals. The rollback plan lives in docs/rollback.md. So this is something that I've stored in coding agent, and now I want to retrieve it via another agent, that is the testing agent. So now let's see how this memory goes from coding agent to testing agent, and what's the role of TiDB Cloud and Mem9. Now I'll try to retrieve that same information via my review agent. For example, this is the API key that I've given. So there's the same memory space that's being shared across different multiple agents. And now I'm now let's go ahead with this and see what the output is. So the output that you can see is it has the agent ID as coding agent, and we are retrieving via review agent. So that means the memory was written by a coding agent and it's retrieved by a review agent, and that means it's shared across multiple different agents, and that has been achieved by Mem9 and TiDB together. Also, at the same time, it is very important that not everything is stored in our memory, and you should not consider that if there's more memory every time then it's better. No, it is not. Temporary debugging noise or there are some passwords or something that are not needed should not be stored, right? The most suitable things to store are project background, user preferences, and much more. So this is something that I wanted to make sure that you are aware, and this is also very important. So that was it for this particular video. Make sure you do check out TiDB, Cloud, Zero, and Mem9 and set it up for your agents for your OpenClaw. Link is then in my description. If you have any doubts, let me know in the comments below and I'll be more than happy to answer. Also, let me know what other videos you want on this channel. I'll be helping you with those videos also very soon. This was all for this particular video. See you in another video. Till then, all the best, good luck, and bye.